Refraction and reflection of plane wave using Huygens principle. First we will discuss about refraction of a plane wave. See here P dash is the interface which separates the medium 1 and 2. Here this is the medium 1 and this is the medium 2. Velocity of light in the first medium, that is v1, and the second medium it is v2. Now see here we took the velocity of light in the first medium is greater than that of the second medium. P dash is the interface which separates these two medium. Now AB is the incident wavefront. See here AB is the incident wavefront. This A dash A, that is perpendicular to this wavefront, that means A dash A represents ray. This is the incident ray. Then the angle between the incident ray and the normal, that is angle of incidence. Here the ray enters from rarer to denser medium. So this is the refracted ray and it bends towards the normal. So this is the angle of refraction. If we take A as center and AE as radius, draw an arc. So this is the position of refracted wavefront. If you take the tangent of that sphere, then you will get the refracted wavefront. Here EC is the refracted wavefront and AB is the incident wavefront. Then what is this angle BAC? See here the angle is I, because you know that these two are perpendicular. This is also perpendicular. So the angle is I. This is the angle between the incident wavefront and the surface. Then the angle between the refracted wavefront and the surface, that is R. Now ABC and AEC both are right triangles. Now we can see what is BC. Now what is BC actually? The wavelets from the incident wavefront reach from the point B to C. The distance travelled by the wave from B to C, that is BC, that is V1t. Here the distance travelled by the refracted ray, that is AE. Here the velocity of light in the first medium is more than that of velocity of light in the second medium. During the same time, the distance travelled by the light in the first medium and the second medium will be different. So V1t is more than that of V2t. When we take the right triangle ABC, what is sin I? Sin I is BC upon AC. When we take the right triangle AEC, what is sin R? That is AE upon AC. We know sin I and sin R, so we can find out the ratio of sin I and sin R. We can see that sin I by sin R is coming V1 by V2. That is the refractive index of the second medium with respect to the first medium. How? Because you know that refractive index of the first medium N1 is equal to C by V1 and N2 is equal to C by V2. Then we will write N21 is equal to N2 by N1. Then sin I by sin R is equal to N2 by N1. That is sin I, N1 sin I is equal to N2 sin R. This is Snell's law of refraction. Now we will write, because already when we discussed here we have seen that this distance BC, that we can take it as lambda 1, that is V1 tau, and here lambda 2, that is V2 tau. Now what is the ratio of lambda 1 upon lambda 2? That is BC upon AE, that is V1 by V2. So we can see that v1 by lambda 1 is equal to v2 by lambda 2. That is a constant, that is the frequency of the light wave. So frequency of the light wave will not change when the ray enters from one medium to another medium. Next we have to discuss about reflection of a plane wave by a plane surface. Mn is a mirror. It reflects the light into the same medium. V is the velocity of light in this medium. Then AB is the incident wavefront. The line perpendicular to AB, it represents the ray. It after incident on this mirror Mn, it reflects. So this is the reflected ray. We take A as origin and V tau after a time interval tau. What will be the distance? That means AE is the distance. Take AE as radius and A as center. Draw a circle. Then tangent to this circle, that is the reflected wavefront. Now AB is the incident wavefront and EC is the reflected wavefront. Now each point on the incident wavefront which sends out wavelets in the forward direction. So here from B to C the wavelet is coming, the same time from A to B the wavelet is there. That means the distance AE is equal to the distance BC, that is equal to V tau. Now you know that the triangle AEC, from the right triangle AEC, angle E is equal to 90 degree and CBA, angle B equal to 90 degree. Then AC is equal to AC, the same side. Now we can say that triangle AEC and triangle CBA are congruent triangle. These two triangles are congruent, that means the corresponding angles also equal. That means angle ECA is equal to angle BAC. That means it is I is equal to R. This is the first law of reflection. Angle of incidence is equal to angle of reflection. Now we will see what happens when a plane wave incident on a prism, a concave mirror and a lens. When a plane wave incident on a prism, you know that these all are rays. The upper portion of the prism is thin, so the rays has to travel more distance through air and less distance through prism. Prism is made up of a material which is having more refractive index than air. So here the speed is less, here the speed is more. So this portion, it has to travel more distance through air, so it can go more distance. And here base side, it can travel less distance only because this portion is thick. So here it is. The same way, when the plane wave incident on a concave mirror, this portion it is curved inwards, so it has to travel more distance, then only it reflect back. So the shape of the wavefront is like this. The same way here, this is a for convex lens. Here the middle portion is thick, here the waves it is going more distance, here less distance, so this is curved this way.